Yes friends, as part of this session, let's understand about circular queue, one of the important data structure algorithm, okay, and also we are going to see its how to develop the code, okay. First let me tell the overall logic and how many scenarios we have to consider to write our own logic, okay. First observe here, what's our concept? Circular queue, okay. What is that? Circular queue. Where we are going to use this circular queue means simple thing. If you want to process any scanning things, there you are going to of course think that you are scanning your entire computer, I mean your entire hard disk, then C drive, D drive, E drive files partially will be scanned, and also we are going to use this circular queue in designing servers, designing servers. Not only one application we can give for all of these, for all of these for all of these circular queues we are having n number of applications. We can state n number of areas where we are using this circular queue, okay. Let it be, if you are having knowledge how to develop code for this one means, then we can use this data structure accordingly in our requirements, okay. Let it be, it is dead similar to normal queue, dead similar to normal queue, but here you have to consider some other few scenarios. I will let you know, observe here, okay. I will let you know those scenarios, observe. Think that you are having one array. Internally, to achieve any of the functionalities of circular queue, we are going to use primary data structure called as array only. We are going to use a primary data structure called array only. We are going to bring circular queue discipline or circular queue what we call that objectives. We are going to bring circular queue objectives by using array only, okay. Now observe here, let me take an array, okay. Let me take one array. So observe here, let me take one array with the size as 5, okay, with the size as what friends? 5, 0, 1, 2, 3, 4. Observe each and every array starting index will be always 0, will be always what? 0. In any programming language, you go and create an array according to the syntax. The starting block index will be always 0. This you have to put in your brain. Based on these tricks only we are going to develop the code, okay. So first thing is what? Always the starting block index will be always 0, okay. Now observe here, what are the circular queue rules or circular queue objectives? Simple thing, whatever the queue type data structure, whatever the queue, like normal queue, circular queue, priority queue, whatever the queue it is, you have to follow 2 pointers, 2 pointers. It is is not C pointers, it is just the cursors. Okay, just 2 pointers or 2 cursors you have to maintain. One small information to you, observe, you have to be concentrating only on these indexes to write any algorithm, getting, which is related to array. Okay, if you are using array data structure and if you are developing any programming, means you have to concentrate only on the index values. Okay, on index values. Okay, and observe here what we are discussing, circular queue. It has number of applications, meaning we are using this circular queue in n number of areas. Okay, based on the requirement you can use this one in designing servers. At the time of designing virus scanners, virus applications, we are going to use this circular queue only. Not only these things, we can use this circular queue in any requirement area. Okay, thing is, here we have to learn first rules, then based on that rules you can write the code in dead simple way. Getting, writing code will be dead simple. Okay, now based by using array only we are going to achieve this circular queue. Without an array we cannot develop this circular queue. Getting, so this primary data structure array is going to be used by us. Okay, primary data structure, getting, primary data structure array we are going to use. Now here I am going to apply some rules, getting, so that we are going to achieve circular queue data structure. Here indexes are very important to us if you are writing any code using array. Now the first rule of circular queue is, observe here, we must have 2 pointers, otherwise cursors. Okay, we must have 2 pointers or cursors. Getting, observe, 2 pointers or 2 cursors means simple thing. Observe here, it's our programming language, we can customize the rules. It is not C language pointers. Okay, it is not C language pointers. Okay, but it will be looking similar to C language pointer. Instead of storing address, I go for index, friends. Please guys who are having knowledge in C, getting, please don't get confused. Okay, observe these pointers, we must use 2 pointers. What are those means? Observe here, number 1 front cursor or front cursor, and other one is what, rear cursor or rear pointer. What this front cursor? Observe what are these means, rules for circular queue. Friends, these and all the rules which we have to follow so that we can achieve circular queue data structure to store our data. If you develop your code by using these rules, that's it, you will get what, circular queue data structure. So the first rule is what, we must have 2 pointers. What is that? Front, rear cursor. Observe here. Now here this front cursor always points head element or starting element, always points starting element. Observe here, front cursor, I will let you know later with programming all of these things. If you understand these things, okay, then writing code will be dead similar. Okay, now front cursor always points what, friends? Starting element. Okay, starting element, and always rear points what? Points latest element or latest inserted element. Okay, latest inserted element. Okay, latest inserted element. Now what is our first tool? We must have two pointers or cursors, and those two cursors are front cursor, rear cursor. Front cursor always points starting element, and rear cursor always points latest element or latest inserted element. Okay, till here no doubts, I hope. Okay, now come to the second point. Okay, second point. Observe here, this is the data structure. Observe here, you are having one structure, you are having one structure at memory to store the data, inserting, right? Storing means first we have to insert the data. If I want, can I delete the data? Yes, I can delete the data. Observe here, without knowing to you, I am talking about inserting. This is one structure. To form this structure, you will have some rules. And to insert, you will have some rules. Okay, observe here. To store data, first I want to insert all of these data. Okay, first I want to insert all of these data, and I think this is what? Unwanted data. All of these data are unwanted data. Now can I delete them? Yes, I can delete them from my data structure. To store a new data, I can store a new data. I can store a new data. So within the data structure, if I want to store data, first I want to insert, and if I feel some data is unwanted data, I want to delete them. I want to insert, I want to delete. So these two operations, these two activities, functionalities is important to us. If you understand how to insert an element within this data structure, observe here, this structure is having rule to insert data one after one. This is first data, second data, third data, fourth data, fifth data. And deletion of this structure is having you have to delete the old data, unwanted data. So now this data has been gone. This is what the rule of this data structure. Think that just for example I am telling. Okay, so a data within a data structure, whatever it is, like linear data structure, hierarchical data structure, you have to insert data to store in it. And if you want to delete unwanted data, if you want to remove unwanted data, you have to perform delete operation. Okay, so insertion, deletion will exist anywhere within any data structure. So in the same fashion, observe here, to store data you have to insert. If there is any unwanted data, I want to take out that data. For that I want to perform delete operation. These two operations will be common for any data structure. Okay, now observe here, for storing, insert; for removing, delete operation. Observe, rule of this circular queue, which was given by some of the algorithm writers who found this algorithm. Okay, that person has given some rules to us. What is that? Observe here. We must delete always. Okay, if you want to delete, okay, observe here, if you want to delete an element, observe here, if I want to delete an element 3, yes, you can delete, no issues. If you want to delete, you can delete 3. If you want to delete newly inserted data, you can delete, no issues, because this is my data structure. I have my rules. I am asking you to delete any data randomly. I am asking you to delete this one or delete this one. This is my data structure, Mohandu data structure. I have rules like that. I have given this data structure, but this data structure is having not much advantage. I think you are coming and doing all operations in random way, but you have to do all the things in a particular organized way. Okay, observe here. In the same way, some of the programmers have given rules for deletion and for insertion. Observe here. For insert, observe here, we must, for insert, we must add or insert element always by using the rear cursor, by using the rear cursor. And now coming to the other one, what is that? We must remove element always by using the front cursor, by using front cursor. That's it. If you know by which cursor to insert and by which cursor to delete, circular queue algorithm we can get finished. Okay, circular queue algorithm we can finish. Okay, now observe here. Okay, now observe. So what we have discussed till now, to develop circular queue data structure, we have to follow some rules or some regulations to achieve this circular queue. So what are those rules? There should be 2 pointers, whereas first front pointer or cursor should point always starting element. It always must point only starting element, and this rear cursor must always point the latest element or latest inserted element. Now coming to insert operation, insert and delete operation. Okay, observe here, let it be insert and delete. Okay, observe, we must add or insert element always by using the rear cursor, This is the basic idea, friends. I will tell the scenarios, then we can write the code dead simply. Okay, observe, we must remove element always by using front cursor. Now as part of this session, let's understand insert operation. Dead simple thing is, you have to put only one thing in your brain, these scenarios. Okay, observe, I'll let you know those scenarios to you. Okay, observe here, observe. So now here let me take an array with 5 elements. Okay, let me take an array with 5 elements. Okay, I said one thing to you. What is that? If we are developing any code or application by using arrays, we must focus on index values. And number 2 is what? Always the first block index will be 0 for any array it is in any programming language. These 2 things, guys. Okay, these 2 things are weapon to us, and we will blindly follow this idea. Okay, everything will be in front of us only. You are not required to put anything in brain. Observe. So let me give the index values 0, 1, 2, 3, 4. Now store. Now observe here. Now that is an array. There I want to store one data. Observe here. Earlier I have given one structure. Now the structure here, it is what? One linear structure. Here I was inserting data in random, in sequential way, and deletion is getting happen in a random way. It's what Mohandu data structure, but this is what circular queue. I think here I am inserting data in a sequential way and deletion is happening in random way. Such type of discipline or such type of rules are having less advantages. To overcome such type of dummy data structures, we are going for circular queue. Okay, now observe here. First rule is what, friends? Observe, if you want to develop any algorithm, there will be rules for any data structure. There will be some rules which was given by the programmers. Okay, those you have to first understand. Those will be the requirements, those will be the objectives for a particular data structure. So as part of circular queue, what is the rules? Two cursors must be there. Okay, and always front cursor points what? Starting element. Please observe, friends, starting element. Okay, and rear always points what? Latest inserted element. Okay, and here we are discussing only add, insert. Okay, we are discussing only add or insert operation, or add or insert functionality. Element, we must add or insert element always by using always by using what? The rear cursor. By using what? Rear cursor. Here you can customize the names. It is not like you have to use only rear, you can customize names also. Okay, but let me take as a general one. Now come here. Now observe, front always points starting element, rear always points what? Latest element. Friends, please observe, if you know these pictorial representations, developing code will be dead simple. Okay, observe. First, do we have any elements here? Within this array data structure, did I store data like 999, minus 9, minus 99, 999? Did I store data like this? No, I didn't store any data within this array. Getting? I didn't store any data within this array. Did I store any data? No data. No data. No data within my circular queue data structure. But please, friends, front cursor always points starting element, rear cursor always points, observe, latest element or latest inserted element. Do we have any latest element? No. Do you have any beginning or start element? No, we don't have anything. At that scenarios, what your front and rear cursors should point. Observe here, you don't have any start element or starting element and latest inserted element within our data structure. So now what these two cursors want to hold? Simple thing, observe. Simple thing, observe. Observe here. Observe here. This is what? -1, right? This is what? Observe here. 0, 1, 2, 3, 4. Left to 0, what will be there? -1 will be there. So if there is no elements means I will make front to point this -1. Observe. Observe how I brought this point. Okay, and if there is no element means even I make this rear to point -1 only. Mister, why only -1? Why you are taking only -1? Why can't you take some other values? Yes, no need to worry. I will even take like any value, 63. You can take. Of course, don't take 63. Don't go for positive values. Okay, take -63 because index cannot be what? Negative value. Getting? Index cannot be as what? Negative value. So somewhere these two cursors are pointing. Observe here, what is the meaning of this one? Means f value equals to -63, r value equals to -63. That is the meaning of this representation. if f value minus 63, r value minus 63, it indicates what? No elements, because observe here, I said one thing to you, array index always starts with 0, getting whatever the array you are creating in any programming language. Now front always points what? Starting element, getting? So observe here, now if front is pointing 0 means what does it mean to us? Observe here, which is invisible here, observe how I am making that one highlight. If front value is 0, observe here, if front value is 0 means what is the meaning of this one? F is not pointing minus 63, it is pointing 0, right? F is pointing 0. It gives the sense to us as what? Front always points starting element or beginning element, getting? So now front is having the value as what here? Minus 63. So if front value is greater than equals to 0, it gives the sense to us as what, guys? Elements exist, getting? Observe here, what is this, friends? If a value is 5 and b value is 9, now how to tell a is less than b? A is less than b. The same expression, b is greater than a. Is it true or not? B is greater than a. The same meaning conveying in two ways, okay? The same thing, observe here, in the same way. If f is minus 63 means, okay, I feel that minus 63, I am sure array indexes always starts with 0 and it ends with a particular index, getting? So if f value is greater than equals to 0, it gives meaning to me as what, friends? Meaning as elements exist in the Q data structure, okay, within the Q data structure. And one more small thing, if rear is also greater than equals to 0, please observe here, if rear is also greater than equals to 0, meaning is what? Elements exist, elements are existing within the circular Q data structure, okay, within the circular Q data structure. Observe here what I have done. First rule is what, friends? We must have two pointers or two cursors. So I have taken two pointers, okay. What is that? F and R, front and rear. Here if you observe, what is the rule to us as part of circular Q? Always front cursor points starting element. First, do you have any elements here like 9, double 9, minus 9, any one random value? No, we don't have any value. Still I didn't insert these values, still I didn't insert any of these values. Yes or no? Yes. So here front should always point the starting element. Here I didn't even insert any element. So to tell that information to JVM or to any interpreter, we have to follow some tricks, hidden tricks. What is that means? I am going to make front and rear to hold one negative value, any one negative value. Why only negative value? Because the data can store only in indexed blocks, within indexed blocks. Getting? Index cannot be negative, friends, okay. Index cannot be negative, getting? Index cannot be as negative, getting? Our index cannot be as what? Negative. That's why I have taken this front and rear as minus, that is holding negative values if our data structure is having no elements. If both are minus or negative values, both are having negative values, it gives the sense to us as what? Empty circular Q. and if front and rear values are greater than equals 0, it gives sense to us elements existing, meaning is what, friends? Elements there, okay, elements existing, getting elements existing, okay. Now observe, this is that thing why I made f1 rear to hold negative values. I hope you understand this one, okay. Now observe here. Now observe, we are discussing, yes, finished, okay. Front and cursor, rear cursor should always point the latest elements, okay. Front starting element, rear latest inserting element, okay. Now observe, we are discussing insert, right? Now we must add insert element always by using what? Rear cursor. By using what? Rear cursor. Observe here, I want to insert an element within this data structure, primary data structure array. By using some rules, I want to achieve circular queue data structure discipline or principles, okay. Observe, that is what we are understanding. Now I want to insert data as 9, okay. I want to insert the data as 9. Yes, you have inserted, mister, no issues, you have inserted the data. Now what is the first element, what is a starting element, and what is latest inserted element, friends? Please, what is starting element or what is latest inserting element here in our scenario? 0th index block element is our starting element and also latest element. 0th block element is our starting and ending, that is starting and latest inserted element, okay. Now observe, what is the rule to us? Front cursor always points a starting element. You should make front cursor to point always starting element or beginning element, okay. Now observe, now please can you increment f value to 0? Yes, so don't make f to refer or hold -63, make this front to refer 0th index, getting. Now f value will be as what, guys, at memory? 0. Now f is having 0, please observe, 0 is what? A pointer only, right?